Welcome back, and thank you for tuning in. In today's video, we are going to do some examples of how to come up with the chemical formulas when you are, or the chemical names when you are given the chemical formula. So we're going to go from formula to name. So just like my previous video, if you watch that, I do have a flow chart. This one's a little bit more involved. So I have this lovely flow chart. If you are again sitting in my class, then you can use the one that I have given you. If you're watching this on YouTube, there will be a link in the description below for access to this, or you could pause the video, take a screenshot, and feel free to use this flow chart however you would like. All right, so it will help you get the correct name from the chemical formula as much as possible every time, following the IUPAC rules. So let's move forward and get into doing our examples. So our first example here is going to be Mg2P3. So I'm going to look up here, are there more than two elements? Well, more than two elements, you're going to count capital letters because each element symbol has one capital letter. So if you count the capital letters, then you'll know how many elements there are. Well, there's two capital letters, so there's two elements involved. Two is not more than two, so I answer no. Are both elements non-metals? Well, Mg is magnesium over here on the left side of the periodic table. So it's a metal. So are both elements non-metals? No. Is the first element a transition metal or one of the following? These are our post-transition metals that are all over here underneath the stair-step line. Magnesium is not one of those. So the answer would be no, and I follow this arrow all the way over here. Write the name of the first element. Well, so I'm going to write magnesium. So I wrote the name of the first element. Then I'm going to write the root name of the second element. Well, the second element is phosphorus. All right, so I look up here. Phosphorus has the root name of phosp. So basically take off the orus. So I'm going to write phosp. And then I add IDE to the end of the root name. So I add IDE. And then I'm done. So magnesium phosphide is our name for Mg2P3. Magnesium phosphide. That's not too complicated. Let's do a number of examples more. I've got quite a few examples to do today, so hopefully you get the process. And as usual, follow the flow chart and you will be good. So CAS, are there more than two elements? No. Are both elements non-metals? No, because calcium is a metal. Is it a transition metal? No, calcium's right here in the alkaline earth metals. So it's not a transition metal. So I follow this around and I'm going to write the name, calcium, and then I write the root of the second element. Well, sulfur is sulf, and then I add IDE. These are not that complicated. In fact, writing the name from the formula is a little bit easier than going the other way. Going from name to formula is a little bit harder. This is the easy one. So calcium sulfide. Let's look at another example. All right. So now I have KHCOO. Okay. Are there more than two elements? Yes. Is the first element hydrogen? No. Is the first element a transition metal or one of the following, those post-transition elements? No, because potassium is an alkali metal. So I'm going to write the name of the first element. K is potassium. So I write potassium. That's pretty simple. And then I'm going to write the name of the anion. All right, it is a polyatomic ion, so I do not change the name of the polyatomic ion. Now, the metal is your cation. Your anion is everything else. So HCOO, that's what I need to look for. So I know it's a polyatomic ion. So I'm going to come over here and I'm going to open up my polyatomic ion list, and I'm going to look for HCOO. It's right here. HCOO is formate. So that is my polyatomic ion's name. So I'm simply going to write formate. So KHCOO is potassium formate. All right. Again, this is not as complicated as the other way around. So now I have my next example. We have Al2S2O33. All right. Are there more than 2 elements? Yes. 1, 2, 3 capital letters. So definitely yes. Now, anytime you answer yes to this first question, that means you're dealing with a polyatomic ion. So you're going to want to have your polyatomic ion list available to you. All right. So are there more than 2 elements? Yes. Is the first element hydrogen? No. Is the first element a transition metal or one of the post-transition metals? No. So I'm going to write the name of the first element. Well, Al is aluminum. So I write aluminum. And then I write the name of the anion. Well, S2O3 is my anion. So I need to look at my polyatomic ion list and find S2O3. All right. So S2O3 is down here at the bottom. S2O3 is thiosulfate. So I'm going to write thiosulfate, and that is my chemical name, aluminum thiosulfate. All right, this is fun. I'm having fun. Are you having fun? Let's have more fun together. All right, so let's do another example. All right, CrO3. Are there more than 2 elements? No. Are both elements nonmetals? No. Is the first element a transition metal? Yes. Cr is chromium. It is a transition metal. So what does that mean? It means I'm going to write the name of the first element. So I'm going to write chromium. All right. So I wrote the name of the first element. Now I'm going to uncross the subscripts to find the charge. So let's look at this. We have CrO3. If I uncross the subscripts, that means I'm going to do the opposite of what we did in the previous video and uncross that. That's a 1 written there, so I'm going to bring it up here to a 1. All right, now I need to check that this gives the correct charge for the anion. All right, this would give me a +3 for chromium and a -1 for oxygen. Well, I know that that's not right because oxygen is supposed to be -2. Okay, so I know that that -1 is not correct. So that means a -2. To get -2, I have to multiply that by 2. Okay, which means this 3 also gets multiplied by 2 to become a +6. So what this tells me is that my charge for chromium is a +6. I use the anion to help me find the charge of my cation. So I know that it's a +6. And now this then tells me to use Roman numerals in parentheses to tell the charge. So chromium 6, and then I'm going to write the root of the second element. That's what it says to do. Write the root of the second element. Oxygen's root is ox, and then I add IDE. So this is chromium 6 oxide. That's actually how we would say it, chromium 6 oxide. The Roman numeral tells us the charge of chromium is a +6. All right. Let's continue on with another example. FeSO4. Okay, are there more than two elements? Yes. Is the first one hydrogen? No. Is the first one a transition metal? Yes. So I'm going to write the name of the first element. Well, Fe is iron. Now I need to write its name in parentheses. I'm going to uncross the charges. Now what I want you to make sure you understand with this one, you should recognize SO4 as a polyatomic ion of sulfate. All right, so that means that that 4 is part of the sulfate symbol. So when I uncross the charges, I'm going to uncross a 1 here, and there's a 1 there that's not written. So does that give me the correct charge? Well, if you're not sure, you look at your polyatomic ion list and you find sulfate, SO4, is supposed to be a -2, not a -1, which means, again, I have to multiply by 2 to give this to be a +2 and this be a -2. All right, because remember, when we go the other way from formula to name, or name to formula, we reduce the subscripts. So we have to unreduce them, basically. So that means iron has a charge of +2. So in parentheses, I'm going to do a Roman numeral 2, and then I write the name of the polyatomic ion. Notice I do not change the name at all, so I just write sulfate. So FeSO4 is iron 2 sulfate. All right. Make sure you pay attention to those Roman numerals and all of that. Let's do some more examples. All right. Whoops. NH4-2Cr2O7. Are there more than two elements? There's a lot more than two elements. Is the first element hydrogen? No. Is the first one a transition metal? No. Write the name of the first element. If it starts with NH4, then write ammonium. Hey, look, this starts with NH4 because that is the symbol for ammonium. All right, so I want you to notice on our polyatomic ion list that all of these are negative except for ammonium. It's the only one that will ever be a cation. So if it is not, then if you see ammonium, NH4, then you know that that's the cation of your polyatomic ion. All right, and now I need to go back over here, and I've written the name. I wrote ammonium. Now I need to write the name of the anion. So let's pull up our polyatomic ion list again, and let's find this Cr2O7. So I scroll down, and I find Cr2O7 is dichromate. Okay, so dichromate is the name of my anion. So I have ammonium dichromate, and that's it. All right. So there's a lot of stuff to look at, or you could memorize all of those polyatomic ions. That would be preferred, but I know memorizing things is kind of a pain sometimes. So there we go. You could memorize them all, or you could just look at all of them, but it's really not that hard. You have ammonium, you have dichromate, so it's ammonium dichromate. All right. PCl5. Are there more than two elements? No. Are both elements nonmetals? Yes. Phosphorus and chlorine are both nonmetals. Is the first element hydrogen? No. So I'm going to use these subscripts to tell the prefixes, and I'm going to write the prefix and name of the first element. So there's no subscript, so that means I have no prefix. I simply write phosphorus. Okay, and then I come over and I write the root of the, sorry, I'm having a brain fart here. We're going to write the prefix and root name of the second element. So this time my prefix is going to be, it's 5, so my prefix is penta. And the root of chlorine is chlor. All right, I find that up here. The root of chlorine is chlor, and then I add IDE. So phosphorus pentachloride is my chemical name for this one. Again, the covalent binary compounds are a whole lot easier than many of the others because, well, the formula and the name kind of go hand in hand. All right, so I have SO2. Are there more than 2 elements? No. They're both nonmetals? Yes. Is the first one hydrogen? No. So I write sulfur, and then 2 means di, and oxygen's root is ox, and then I add IDE, sulfur dioxide. Okay, not all that complicated, and you can follow through all of the flowchart rules to get there. All right, let's move on. N2O5. Okay, are there more than 2 elements? No. Are both elements nonmetals? Yes. Is the first element hydrogen? No. So I'm going to do the subscripts and prefix thing again. So this time I have a subscript in my first one. So that 2 is di, and the element is nitrogen. So I write dinitrogen, and then my prefix is going to be penta again because it's 5. And oxygen is OX and IDE. Now, if you remember from the last video, I mentioned this. The prefix is penta, but since my element name starts with an O, we don't want to have pentoxide because that's just kind of weird and cumbersome to say. So when my element name starts with an O or an A, we don't write that a second time. So we drop the A off the prefix. So it's pentoxide instead of pentoxide. So just pentoxide. So dinitrogen pentoxide. And that is that one. A few more examples. All right. HCl. Are there more than 2 elements? No. Are they both nonmetals? Yes. Is the first element hydrogen? Yes. So I'm going to write hydro. All right. And then I'm going to add the root name of the other element. So the other element would be the one that's not hydrogen. So the other element here is Cl. So the root of chlorine is chlor. And then I add ic acid. So hydrochloric acid. Okay, hydrochloric acid. That's the binary. So you'll notice all binary acids are going to start with hydro in their name. Okay, that's what makes them recognizable as a binary acid instead of an oxyacid. Oxyacids are not going to have hydro in their name. We talked about that a little bit in the previous video. All right, so let's move on to another example. So the last one was hydrochloric acid. This one is HClO3. So this time, are there more than 2 elements? Yes. Is the first element hydrogen? Yes. So I'm going to write the name of the oxyanion. That would be everything after the H. So ClO3. So I need to come over to my polyatomic ion list, and I need to find ClO3. Well, here it is. So that's chlorate. So I'm going to write the name of my ion. I'm going to write chlorate, all right? And now what this tells me is that if it ends with 8, I'm going to change it to ic acid. So the 8 is going to get changed to ic acid, which means I have chloric acid. So hydrochloric acid was just HCl. It was the binary one. Chloric acid is the oxyanion, or the oxy acid, where we have HClO3. Okay, we have the polyatomic ion of chlorate there. Okay, so make sure you follow the flowchart and get it correctly, because it can be fairly confusing. Hydrochloric acid and chloric acid are fairly different compounds. Okay, so now we have HClO2. The last one was HClO3. This was HClO2. So are there more than two elements? Yes. Is there hydrogen in the first one? Yes. So I'm going to write the name of the oxyanion. So again, I need to go back to my polyatomic ion list, and now I need to find ClO2. Well, ClO2 is chlorite. So now I'm going to write chlorite. Okay, but this time I'm going to change it. All right, we're going to change the ending. Ate becomes ick. Well, this is ite. Ite becomes OUS, or us. Ate ick, ite us. So my ite is going to change to OUS, and I'm going to end up with chlorous acid. So we had chloric acid, we have chlorous acid. They are different, and you'll notice the formulas are different as well. ClO2 is different than ClO3. The number of oxygens makes a difference to how the acid works. Okay, so let's do one more example. H2SO4. Okay, are there more than two elements? Yes. Is the first element hydrogen? Yes. So I'm going to write the name of the anion. All right, so that's sulfate, SO4. So just to show you on the polyatomic ion list, I'm going to find it. It's SO4 is sulfate. Now I chose this one for a reason, because this is one that is a little bit different than some of the other compounds. So sulfate, I do want to make sure you note something. Up here, if you look at your flow chart, it says sulfur, the prefix is sulf. If it is in an acid, then sulfur. All right, so what that means is when I change the name here from the ate to ick acid, as the flow chart tells me to do, we don't just write sulfic acid because that sounds weird to us. So we're going to write sulfuric acid. All right, sulfur and phosphorus are that way. So when we do hydrosulfic, it's not hydrosulfic, it's hydrosulfuric acid, and phosphoric acid instead of phosphic acid. So the prefixes, make sure you are familiar with that. Phosphorus and sulfur, instead of these normal roots that you see up here on the flow chart, they're going to be the full name, phosphor and sulfur. All right, so those are the only two that are like that. So you just kind of got to get used to that with practice. All right, so sulfuric acid is our name for this compound. All right, so that is it for our examples of going from chemical formula to name. I've gone through pretty much every part of the flowchart now. So make sure you, again, follow the flowchart. And if you do that every single time as you practice these, as you see the ones that you're assigned and you keep practicing them, the more you do it, the less you will need the flowchart, and you'll be able to do it without the flowchart. And that's the goal, that you learn how to do it without the flowchart, without memorizing a whole bunch of the rules. This flowchart utilizes the rules from IUPAC naming without making you actually memorize all of the rules. So hopefully that helps you out, and thanks for watching. Have a day.